In this segment, we're going to talk about the mass-luminosity relationship on the HR diagram along the main sequence. On this HR diagram, I have drawn a bar from upper left to bottom right, and that represents the main sequence on the HR diagram. And this HR diagram is comparing the luminosity of the star relative to the luminosity of the sun versus the temperature at the surface of the star. Along the main sequence, mass increases from bottom left to upper right. So more massive stars are located at the upper left, and the least massive stars are down at the bottom right. Let's look at this trend on an HR diagram from your textbook. As shown, mass varies from the bottom right to the upper left along the main sequence on the HR diagram. Notice the numbers of masses in the giants and the supergiants. They don't seem to have a general trend direction. I can only tell you how the mass varies along the main sequence. And luminosity, as you know, increases from bottom to top. So we have a relationship between mass on the main sequence to luminosity on the HR diagram. That relationship is the luminosity of the star is equal to the mass of the star to the 3.5 power relative to the luminosity of the sun and the mass of the sun to the 3.5 power. This is the mathematical form of the mass-luminosity relationship of stars on the main sequence of the HR diagram. Let's compare luminosity to the mass of a star. Now this diagram from your textbook is comparing luminosity on the vertical axis, or absolute magnitude on the vertical axis, to the mass of the star on the horizontal axis, and is not an HR diagram. Now the mass is not mass to the 3.5 power. We're only comparing the mass of the star relative to the mass of the sun. So let's say you have a star's mass of 1 compared to the mass of the sun. In other words, an equal mass object compared to the mass of the sun. Now what is its luminosity? Well, we can just draw up to the line and then go across, and we see that the luminosity compared to the luminosity of the sun is 1, or in other words, the luminosity of the star is equal to the luminosity of the sun, because I multiplied both sides of the equation by the luminosity of the sun, which canceled on this side, and 1 times the luminosity of the sun is equal to the luminosity of the sun. Let's look at the mathematical version. If we know that the mass of the star is equal to 1 times the mass of the sun, then we substitute that into the equation. And we have the luminosity of the star relative to the luminosity of the sun is equal to 1 times the mass of the sun for the mass of the star divided by the mass of the sun to the 3.5 power. The letters cancel, and you're left with a value of 1 to the 3.5 power, and 1 to the 3.5 power is just 1. Therefore, the luminosity of the star relative to the luminosity of the sun is equal to 1, or the luminosity of the star is equal to the luminosity of the sun. Let's do another example. Let's say the mass of the star is equal to 10 times the mass of the sun. Well, if we divide both sides of the equation by mass of the sun, then you have mass of the star divided by the mass of the sun is equal to 10. So we find the 10 in the graph, and we go up to the red line, and we go across, and we read off the luminosity. So the luminosity is roughly between 10 to the 2 and 10 to the 3, so right in 10 to the 4, and right in between is 10 to the 3, and if we break it up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 gradual, we see that it's about equal to 2 times 10 to the 3. So the luminosity of the star divided by the luminosity of the sun is around equal to 2 times 10 to the third. Or the luminosity of the star is around equal to 2 times 10 to the third luminosity of the sun. Let's look at the mathematical version of this. So the mathematical version is that the luminosity of the star relative to the luminosity of the sun is equal to the mass of the star divided by the mass of the sun to the 3.5 power. So we know that the mass of the star is equal to 10 times the mass of the sun. So we substitute that into that equation. We have the luminosity of the star to the luminosity of the sun is equal to 10 times the mass of the sun divided by the mass of the sun to the 3.5 power. The letters cancel out, and we're left with a 10 to the 3.5 power, which is the same thing as 10 to the first power times 10 to the first power times 10 to the first power times 10 to the half power. If we multiply the first three together, we get 1,000 multiplied it by 10 to the 1/2 power, which is the same thing as 1,000 times the square root of 10, which is the same thing as 1,000 multiplied by 3.162. And if we multiply that out, we get 3.13162 for the luminosity of the star relative to the luminosity of the sun. Therefore, the luminosity of the star is 3,162 times the luminosity of the sun, which is approximately what I was getting from the graph. So the numerical equation is much more accurate than reading off the graph. Reading off the graph is going on this red line, whereas what we're doing with the numerical is we're actually calculating the dots. Let's say the mass of the star is 0.1 times the mass of the sun. So the mass of the star divided by the mass of the sun is equal to 0.1. What is the luminosity of the star? We substitute 0.1 into the mathematical equation and solve. So we're going to get 0.1 to the 3.5 power, which is equal to 0.1 times 0.1 times 0.1 times 0.1 to the 1/2 power, which is equal to 0.1 cubed times 0.1 to the 1/2 power, which is equal to 0.0003162, or in scientific notation, 3.162 times 10 to the -4th. So therefore, the luminosity of the star is 3.162 times 10 to the -4, the luminosity of the sun. And this star is very dim compared to the luminosity of the sun, which is located there. So in summary, if you know the luminosity of a main sequence star, you can determine its mass. Likewise, if you know the mass of a main sequence star, you can determine its luminosity.